Jai Hind all. I am Dr. Garima Varshney, Assistant Professor in ECE Department of AKG-EC. Okay, so today we will be discussing nodal analysis, which is a very important topic of the subject BEC 303, which are in second year. Okay, so first of all, what is nodal analysis? This is a technique to solve the voltages of any circuit. In nodal analysis, first we select a reference node which is generally assumed to have a zero potential, and then we apply KCL to each non-reference node. That means the circuit will consist of various nodes. One is a reference node and the other nodes are non-reference nodes. So, we will apply KCL to all non-reference nodes. Then, after applying KCL, we use Ohm's law to express the branch current in terms of the node voltages. And then, we solve these equations which we will be getting after applying KCL and Ohm's law. We will be getting some equations which will consist of unknown node voltages. Let's say there are two nodes. So, two variables will be there, V1 and V2 node voltages, and then we will be getting two node equations. So, two equations will solve two unknown variables. Okay, so let's discuss this nodal analysis using some circuits. So, first see this circuit. This circuit consists of two nodes. This is node 1 and this is node 2. Let's say the node 1 have voltage V1 and the node 2 has voltage V2. So, there are two nodes V1 and V2, and see this node is the reference node. The reference node has the voltage 0 or ground. So, now the first step is we select a reference node and give voltages to the non-reference nodes. Now, apply KCL to non-reference nodes. Okay, so this is the node 1. Say there are three currents because node 1 has three branches. So, there will be three currents in these three branches. Say this is current I1, this is current I2 and this is current 5 amperes. Okay. Now, at node 2 also mark the currents. Say this is current I3, this current is again I1, this current is 5 amperes and this is 10 amperes current. Now, we have marked all the currents on the nodes. Now, apply KCL at node 1. KCL at node 1. What does the KCL say? The KCL say that incoming currents at node 1, incoming currents must be equals to outgoing currents. So, what are incoming currents at node 1? See, this I1 is outgoing current, I2 is also outgoing current, but the 5 ampere current is incoming current. So, incoming current is 5 ampere must be equals to outgoing current. Outgoing current is I1 and I2. So, I1 plus I2 must be equals to 5 amperes. Now, apply Ohm's law to find out the values of I1 and I2. So, this I1's value will be V1 minus V2 by the value of resistance. So, 5 is equals to values of I1 is V1 minus V2 by 4 and the value of I2 is V1 minus 0 by 2 ohms. So, value of I2 is V1 minus 0 by 2 ohms. Now, rearrange this equation, we will get 3V1 minus V2 is equals to 5. This is our equation 1. Now, apply KCL at node 2. At KCL, now apply KCL at node 2. See, at the node 2, what are incoming currents and what are outgoing currents? So, I1 is incoming current and 5 ampere is outgoing current, 10 ampere is outgoing current, and I3 is also outgoing current. So I can say I1 is equals to 5 plus 10 plus I3. This is KCL at node 2. Incoming current is equals to outgoing currents. Now find out the values of I1 and I3 according to the Ohm's law in respect to the voltages. So I1's value is V1 minus V2 by 4 is equals to 5 plus 10 plus I3. What is the value of I3? I3 is V2 minus 0 by 6. So this is V2 minus 0 by 6 ohms. Now we rearrange this equation. We will be getting, now apply KCL at node 2. So KCL at node 2. Okay, what are incoming currents at node 2? I1 and 10 amperes are incoming currents. So I1 plus 10 are incoming currents. What are outgoing currents? Outgoing currents are I3 and 5 ampere. So I3 plus 5 amperes are outgoing currents. So now I1 and I3 values in V1 and V2. So I1 will be equals to V1 minus V2 by 4, V1 minus V2 by 4 plus 10 is equals to, what is the value of I3 in terms of V2? V2 minus 0 by 6. So V2 minus 0 by 6 plus 5. So now rearrange this equation. We will be getting V1 minus V2 by 4 minus V2 by 6 is equals to minus 10 plus 5, which will be equals to V1 minus V2 3 by 12 minus 2V2 by 12 is equals to minus 5, which will be equals to 3V1 minus 5V2 is equals to minus 60. So we are having this equation 1 and this equation 2. So these are two equations having two variables. Solving these two equations, we will be getting the values of V1 and V2. Use your calculators to solve these equations. The values of V1 and V2 you will be getting as 13.33 volts and V2 will be equals to 20 volts. So now you get the node voltages value for this circuit. V1 is 13.33 volts and V2 is 20 volts. Now, whatever parameters are being asked in the exam, you can calculate those parameters. Such as, if in the exam or in the circuit, you have to calculate the current through 6 ohms. So, the current through 6 ohms will be V2 minus 0 by 6. You have V2's value. So, you can calculate the current through 6 ohms. Now, let's take a second circuit. Okay. Now, this circuit consists of a dependent voltage, dependent current source. This is a dependent current source whose value is depending upon the current through this branch, right? Okay. So, now we can see there is a reference node having 0 volt potential and there are 3 nodes, node 1, node 2 and node 3. Assign voltages V1, V2 and V3 to these 3 nodes. Now, the second step is apply KCL on these 3 nodes. So, KCL first node, first mark all the currents. Okay. So, this current is 3 amperes. 3 amperes current, 3 amperes. Now say this current is I1 and this current is Ix. It is written over there. Okay, now mark all the currents at node 2. So this current is again Ix, say this current is I2 and this current is I3. And now mark all the currents at node 3. This current is I3, this current is I1 and this current is 2Ix. Now apply KCL at all three nodes. First, KCL at node 1. KCL at node 1. Incoming currents. What are incoming currents? 3 ampere is incoming current only. Ix is outgoing current and I1 is also outgoing current. So 3 is equals to I1 plus Ix. Now the value of Ix and I1 in terms of node voltages will be 3 is equals to, what is the value of I1? So I1 value will be V1 minus V3 by this 4 ohm resistance. So I1 is V1 minus V3 by 4. Now what is the value of Ix in terms of node voltages? V1 minus V2 by 2 ohms plus V1 minus V2 by 2 ohms. Fine. Now rearrange the equation. You will be getting, multiply this by 2 and denominator by 2. So now this is 3V1 minus 2V2 minus V3 is equals to 12. This is your equation 1. Now apply KCL at node 2. At node 2, what are incoming currents? Ix is only incoming current while I2 and I3 both are outgoing currents. So incoming current is equals to outgoing currents. Now the currents in the terms of node voltages. What is the value of Ix? V1 minus V2 by 2. So this is equals to V1 minus V2 by 2 is equals to, what is the value of I2? I2 will be V2 minus 0 by 4 is equals to V2 minus 0 by 4. And what is the value of I3? V2 minus V3 by 8 plus V2 minus V3 by 8. Now rearrange this equation. We will be getting this will be equals to 4V1 minus 7V2 minus plus V3 is equals to 0. This is equation 2. Fine. Now KCL at node 3. KCL at node 3. So what are the incoming currents at node 3? I3 and I1 are incoming currents at node 3. So I1 plus I3 must be equals to, the outgoing current is 2Ix. 2Ix. Fine. So I1 value of I1 in terms of node voltages will be V1 minus V3 by 4 plus, what is the value of I3 in terms of node voltages? V2 minus V3 by 8, V2 minus V3 by 8 is equals to 2 into Ix. What is the value of Ix? We can find Ix from this branch. Ix is V1 minus V2 by 2. So put this value V1 minus V2 by 2, 2Ix. Now rearrange this equation. We will be getting 2V1 minus 2V3 plus V2 minus V3 is equals to 8V1 minus 8V2 which is 6V1 minus 9V2 plus 3V3 is equals to 0, or it can be written as 2V1 minus 3V2 plus V3 is equals to 0. This is equation 3. So now we are having 3 equations. Use your calculator to solve these 3 equations, and you will be getting V1 is equals to 4.8 volts, V2 is equals to 2.4 volts, and V3 is equals to minus 2.4 volts. These voltages you will be getting by solving these 3 simultaneous equations in 3 variables. Now moving further, okay, now there is a special case in which a voltage source is connected between two nodes. A voltage source is there between 2 nodes V1 and V2. There is a voltage source. So this is a special case for the nodal analysis in which this V1, V2, this node 1 and node 2 will be called as super node. So what we can say, node 1 and node 2 are super nodes. So super nodes are those nodes in which between the 2 nodes there is a voltage source. The voltage source can be dependent or independent. Further, what is the procedure to solve this type of circuits? We just remove this, whatever elements are connected between these 2 sources. Like in these 2 nodes there is a voltage source and there is a resistor. So these 2 elements will be disconnected and we will treat this node as one node. V1 and the node 1 and node 2 will be considered as one node. Let's solve the circuit. Okay, this is a circuit in which this is a super node. So we need to remove the elements which are connecting between node 1 and 2. So now the new circuit will look like this. Okay, so these 2 elements I have removed, but now node 1 and node 2 will be considered as a single node, which is called as super node. So now I will apply KCL at super node. So apply KCL at super node 1-2. Super node 1-2. Now, whatever currents are coming at node 1 and whatever currents are there at node 2, we will treat all these currents all together at a single node, super node. So, at node 1, I1 is the incoming current. So, incoming current is I1. All other currents, I2, I3 and I4, all are outgoing currents. So, incoming current is equals to I2 plus I3 plus I4. What we have done, we are treating node 1 and node 2 as a single node, which is called as super node. Whatever currents are there at node 1 and node 2, we will apply KCL altogether to all these currents. So I1, I2, I3 and I4, 4 currents are there. all together at node 1 and 2. So I1 is the incoming current, while I2, I3 and I4 all are outgoing currents. So KCL at supernode 1 and 2. So what is the value of I1? I1 is 2 amperes is equals to, what is the value of I2? This is voltage V1 and this is voltage V2. What is the value of I2 in terms of V1? This is V1 minus 0 by 2 plus, what is the value of I3 in terms of V2? It is V2 minus 0 by 4 plus, what is the value of I4? I4 is given as 7 amperes plus 7. Now rearrange this equation. So this will be 8 is equals to 2V1, 4V1 plus 2V2 plus 28. No. So this equation will be 8 is equals to 2V1 plus V2 plus 28. Now 2V1 plus V2 is equals to minus 20. This is equation 1. There are two variables, but I am having one equation only. Now the second equation, I will get the second equation through this supernode. What the supernode is saying? The supernode is saying the difference between these two nodes is 2 volt. That means supernode is saying that V2 minus V1 is equals to 2 volts. Supernode equation. The difference between these two nodes is 2 volts. So second equation I am getting from the supernode. Now you have two unknowns, two equations. You can solve this equation using your calculator. So now you will be getting V1 is equals to minus 7.33 volts and V2 is equals to minus 5.33 volts. This is the answer. So in the last, concluding this lecture, we have discussed two circuits. One was a simple circuit, consists of independent voltage current source, and the other circuit having a dependent current source, and the last circuit is consisting of a supernode. Thank you. Jai Hind.